What would it take to make water flow on a world where the average temperature is 80 below zero? Or turn bare rock and dust into soil where forests could grow? What would it take to terraform Mars? Create a planet more like Earth, where humans could breathe the air? It would cost billions and take hundreds, if not thousands of years to accomplish. But transforming Mars from a barren rock into a living world is not as far-fetched as it may seem. And our long-term survival could depend on it.
To create the base on Mars, we will use a two-phase approach. In Phase 1, an ecosystem of 3D printing robots will arrive months in advance of any human explorer. They will construct a protective shield for the base by adopting a modular robotic swarm strategy, a plan that allows for redundancies and enhances the odds for success. Intelligent autonomous robots will have interchangeable roles, from battery storage to scout rovers, logistics to excavational, and even 3D printing units, all integrated with multiple cameras and sensors for navigation. They can reconfigure themselves for a multitude of purposes, ensuring prolonged usage beyond the initial build phases. The smallest configuration is the one-wheeled scout rover that uses ultrasonic scanning to analyze the Martian surface to determine the best regions for obtaining optimum regolith. The digger receives the location coordinates and then excavates the Martian soil. It then delivers the payload to the refining assemblies. Here, large chunks of Martian regolith can be processed down to a finer grain and then delivered to the melter robots in situ. They then use concentrated microwaves to melt the regolith and extrude through the 3D printing nozzle. The shell is autonomously 3D printed, layer by layer, over several months by the robotic system.
The planet's gravity is almost equal to Earth's. Venus has a dense atmosphere that could shelter colonists from radiation. In addition, there's a huge amount of carbon dioxide accumulated in the atmosphere of the planet, and oxygen can be extracted from it. But there's a problem. Behind Venus's thick veil lies a living hell. Large quantities of carbon dioxide in the atmosphere create an extreme greenhouse effect and raise the temperature to about 475 degrees Celsius. The atmospheric pressure on Venus is about the same as the pressure at a depth of 900 meters underwater on Earth. So even the most protected probes would only survive for a few hours there before being flattened by the gigantic atmospheric press. The planet's upper atmosphere is also flooded with poisonous acid rain, many times more corrosive than the most acidic rain on our planet. And the wind, at a speed of 360 kilometers per hour, blows away everything in its path. So why do scientists still consider colonizing such a horrible planet? It turns out that Venus hides a place like Earth. At an altitude of about 50 kilometers, there's a region with a level of pressure and gravity almost like that found on Earth. And the temperature there is about 30 to 50 degrees Celsius. So building floating habitats behind the planet's clouds might be a good idea.
This is Marcia, designed by AI Space Factory. It has windows, multiple floors, private rooms, and even a skylight. But best of all, NASA loves it. The rocket scientists and engineers at NASA are pros when it comes to landing robots on Mars. And they're figuring out how to get humans there next. But when it comes to living on Mars, well, they decided to ask the public for help. In the 2010s, NASA launched its 3D printed habitat challenge. Over the years, it's held multiple stages of the challenge that started with virtual designs and has since progressed to full-fledged 3D printed models. Challengers compete not only for bragging rights, but for, money. And in 2019, first prize was $500,000. Challengers were judged on multiple criteria, including the material they used, the structure's durability, and how airtight it was. After 4 days of building, testing, and judging, NASA announced the winner.
First place goes to Team AI Space Factory.
As more sophisticated 3D printing robots arrive, larger hydroponic crop facilities are built, generating the majority of the food for the Martian settlers. Kimball Musk even has a team working on Mars with their own vertical farm. The settlers begin testing underground digging for habitat purposes. Data is sent back to the Boring Company on Earth. Space agencies from all around the world are now sending their own equipment and scientists to Mars Base Alpha. The domain name Amazon.Mars is registered by Jeff Bezos. Blue Origin plans to open for delivery to Mars for space agencies first and then later for private clients. The new Starship crew have transported fishes from Earth to create an aquaponic greenhouse, as there is now enough water being made on Mars. The first funeral is held, the settler is cremated and spread across the Martian landscape. Back at Earth, a fleet of starships full of fuel, cargo, and passengers is waiting in low Earth orbit. When the launch window opens, they fly as a fleet to Mars. The spacecrafts are able to support and dock with each other if needed during the 7-month journey.
So let's tackle those challenges. The first big one would be setting up a habitat that could support large numbers of humans, protect them from the cold and frequent dust storms, provide breathable air, safe drinking water, a way to produce food, and a shield against lethal cosmic rays. No big deal, right? Step 1 would be a large enclosure to act as a central hub for our 1 million Martian colonists. This has often been envisioned as a city beneath a big glass dome, providing light but also protection from the elements. Elon Musk has also speculated that this could be a good formula for his Mars colony, saying that a pressurized glass dome with parks and plant life could be a very pleasant way to live during the long process of terraforming Mars into a more hospitable home. But in order to have a functional colony beneath this utopian dome, you'd need a way to power it. The current frontrunners for powering a Mars base are solar and nuclear, depending on who you ask. Solar obviously comes without the risk of accidental irradiation, but it will require a lot of land area for solar farms. That shouldn't matter though, since Mars is currently nothing but open land and the colony will be fairly small.